Hello, guys and girls. The program you are about to hear will be both fun and educational, but it is not a substitute for medical advice. Although we are doctors, we are not your doctors. Hello and welcome to Travel Medicine. As always, I'm your friendly neighborhood internal medicine doc, Dr. J.
Hi guys, Dr. Santhosh here, coming at ya! No, I'm really not, I'm just sitting here.
You had me scared there for a moment. He's coming right for us.
Through your speakers. I love how shock jocks do that. Coming at you, through your headphones! No,
Sunday.
You're really...
Anyway, it is once again time for, and I think our first one of this season, time for a journal club.
Yes!
There was a lot that happened between the end of our second season and coming back. So we have a whole heap of journal. It practically has me tearing my hair out with frustration. Beards and hair in general used to be thought of as a means of warding off illness. And in fact, do you know, really men didn't start wearing beards until around the Victorian era?
This was very, very true in Europe, by and large. I remember learning about, especially in the Roman Empire, that you would have a slave's beard, or you would be more clean-shaven, meaning that you had the luxury of time and clean water and a razor to actually either trim down your beard or shave it off.
But, everybody is... the beard is constantly being worried about from both ends of the health spectrum. I don't know if you remember, what was it, maybe 4 or 5 months ago, there was a big concern that, there were a whole bunch of bacteria hiding in our beards.
And there was, actually, I remember a great little bit on Conan O'Brien where Will Forte actually had the bacteria in his beard sampled and sent to us at UCLA to get cultured. And, we found quite a few things, but it shouldn't be surprising because a lot of those same bacteria live on our skin. They just get a nice, warm, sometimes damp place to grow when you've got a lot of fur around there.
Well, I'm glad you bring that up because, beards also used to be a sign of virility. And in fact, I love this quote from Dr. Withy at Exeter. He said, "Growing a beard is the only way a man can publicly display his manhood without getting thrown in jail for indecent exposure."
That's fantastic. Yeah. in this is... Here, see my manliness on my face.
Dr. Withy went and did a study of beards because why not?
This is the power of science.
It turns out that round about mid-1800s, 1850, right in my favorite Industrial Revolution Victorian period, a lot of doctors were writing prescriptions for beards to men as a means of warding off illness for things like sore throat.
Makes kind of intuitive sense, right? If you are just learning that there is something transmitted through the air that could make you sick, right? So that we've discarded theories like the humors, where there's some kind of imbalance in your body, that there's actually something transmissible that float through the air and you can breathe it in and make you sick. Well, what do you need? You need a filter. And, your beard's on your face anyway, and it's a dense thing that strains out some particles from time to time. So put one on your face and filter out all the bad vibes.
And others saw it as a means of relaxing the throat, especially for people whose work involved public speaking. That has almost nothing to do with the rest of the episode. I just found it fascinating that at one point, I could have told my patients, I prescribe 2 weeks beard.
I'd come around the corner. Doctor, are you mad? 2 weeks of beard is not nearly enough beard.
Well, it sounds like someone is in a hairy situation.
This is a prickly situation.
I have a few more mustache puns, but I'll shave them for later.
I feel myself kind of stumbling through the material for this bit.
Well, as long as you keep a stiff upper lip.
I'll try not to. Chin up. Chin up.
Don't get cheeky. I was having so much fun with that, I almost forgot about our next story, and that would have been a true shame, and also quite ironic. There's a lot of things I think people want to forget, our most recent election not least among them, but something that you may not have known happens this week, or maybe you knew and forgot, is that on Monday, President Obama proclaimed November National Alzheimer's Disease Awareness Month.
In this case, it's a little ironic. At least he didn't call it remembrance. But
of course, Alzheimer's, although we do joke about it, is a very serious disease, affects quite a large number of Americans, and part of the real tragedy is we have to watch our loved ones sort of slip away without any real treatment or anything that can be done to halt, slow, or fix the disease. Well,
right.
That may not be the case for the, we'll say, distant future. And Santhosh, do you want to talk about what this latest article from Scientific American and Science Translational Medicine said?
There's a buildup of beta amyloid protein, and this is basically a tangled up, messed up protein. And there's another component of plaques. And so focusing on the beta amyloid protein, we've always thought that if we could make sure that that beta amyloid protein does not accumulate in the brain and start causing damage to the neurons, we could stop Alzheimer's in its tracks. So maybe not quite reverse it, but at least you could stop it. So this particular article reviewed the effects of the team from Merck Research Labs looked at an inhibitor of a protein called BACA1, beta site amyloid precursor protein, cleavage enzyme 1. Scientists, please.
Scientists and their naming. We've talked about this before.
Yeah, seriously. All you had to call it was like, amylo splitter. Yeah. You could have come up with so many things. But essentially,
Forget-me-not.
This
Forget-me-not compound number 1
takes the beta amyloid precursor, so before it's beta amyloid protein, which causes damage, it takes the precursor protein and tears it apart. So it cleaves it so that the beta amyloid protein is left behind and it accumulates. So what you do is you go to that enzyme and you block it. So you inhibit it or you stop its enzymatic activity from continuing. So BACE1 blocker is now called verubecestat.
Which sounds like a country somewhere in the Middle East.
There you go. That should stop or slow the accumulation, the production of beta amyloid protein. So if this works somewhere in the future, they're hoping to target the year 2025, we will see a real drug which can slow the progress of Alzheimer's.
The exciting thing is it's already entered human trials. It's not without side effects, and the good news is they haven't seen a lot of evidence of any toxic side effects. It reduces, as Santhosh said, these amyloid proteins and precursor proteins in the cerebrospinal fluid of healthy adults who had taken the drugs for 2 weeks and patients with mild to moderate Alzheimer's who took it for 1 week. But there's no real knowledge of what dosing levels should be. And right now, the only obvious side effect, and part of why scientists are so excited, the only obvious side effect when they tested it in mice and rats and monkeys was reduced fur pigmentation, which is not a big deal because there are some humans who would pay a lot for reduced fur pigmentation.
Oh man, my fur pigmentation, just gets in the way, I swear.
So there's 2 trials that are aimed at testing long-term outcomes in patients that are ongoing. The first has about 2,000 people with mild to moderate Alzheimer's who are taking this drug for 18 months. And the second has about 1,500 people who are showing early signs of Alzheimer's, meaning only detectable by imaging and not by symptoms. And they're being followed for 2 years.
So we're looking for results to be available in 2017 and the second one in 2019. And that doesn't mean that anything will be published at that time. That means that we'll have results that we'll be able to analyze. So usually it takes about 6 months to a year from when the results are received by a scientist from a trial analysis to get to publication. It's a real good time actually to just talk briefly about clinical trials. So what we're talking about is phase 1 is done, which is where you check for safety. Phase 2 is actually checking for effectiveness. So that's the really small trial and where we have our results right now that, hey, this is safe and it works in small numbers. And this next step is phase 3, where you confirm the findings of phase 1 and phase 2 in a larger population and by much more stringent metrics. So this is a great place to start. And the final steps really, hopefully by maybe 2025 or so, is to really have these medications in production so that, we can't reverse Alzheimer's once it starts because the amyloid protein that's already built up is going to stay there. But we could stop more from accumulating. So you really could stop the disease in its tracks.
Let's move on to our next story, which is actually, it's a little bit of a trip down memory lane. Was on, well, why don't we just say bowels and movements?
Because everything comes down to poo.
Well, we are constantly finding new things in the poo. We are constantly finding new things in the poo. And you always have to remember to check it. And the latest we may have discovered is hiding deep inside your bowels may be the next hot antibiotic. And this thing is the shit. Santhosh, why don't you tell us how?
Yeah, sometimes your puns are just a pain in the ass, I swear. Alright, so guys, if you haven't listened a few episodes back to some of our earlier journal clubs, we were very excited about an antibiotic called tiorbactin, where people went through soil and found antibiotics growing in everyday sand and mud. Well, this is a step deeper into ourselves, where researchers actually screened the bacteria in our bowels. And so, you're talking about taking stool samples, looking through hundreds of thousands of species of bacteria that live in there, which pretty much all of which are happy little bacteria. They help us break down stuff. And say, hey, all of these little microbial communities have ways to make their own little space. So they stave off the other bacteria. So they make little molecules and peptides and other things in order to do this. I wonder, exploit any of these to treat the bacteria that's harmful to us, like MRSA or methicillin-resistant Staph aureus. And it turns out that yes, we can. The wonderful researchers at Rockefeller University, I should say the Rockefeller Center, went ahead and checked the poo. They delved deep, and they found a class of chemicals called humamicins, which are hiding out in there, made by some of our friendly bacteria, that when put up against MRSA in a dish, or even in a mouse model, will kill the MRSA dead. And this is just wonderful because, well, if you take an antibiotic from the soil, you got to say, okay, is it safe for humans? Can we use it? Yada, yada, yada. But here, this little molecule is going through our bowels right now, Josh. It's in our bowels, and we seem to be safe. We seem to be safe. It's not melting away our bowels or anything. That means that we already have one little step of proving safety, not completely. The amounts that we've been using this in to treat MRSA clinically would be quite different. It tells us that we have something just right there in our bowels, ready to use as a weapon against MRSA and potentially other bacteria as well. They're using the stuff that we eat for energy, right? So that means that they need to kind of sequester a little bit of fat, a little bit of carbs.
Now, if you think of your bowels as, a series of gated communities, each of who is constantly coming up with new ways to keep anyone from immigrating into their community. Right, so a certain group of bacteria will stake out its area, and there'll be the rest of your microbiome, all the bacteria that make up the theme park that is you, all living around. And each of those bacteria have come up with ways to hold on to their territory. And one of the ways they defend is by coming up with weapons that we can use to fight, as Santhosh said, these other invasive.
Oh man, it's so they're making the weapons that we need right there. It's fermenting in our gut as we speak. If you have the chance, not in a paywall, please do read it, because aside from finding these really cool molecules, the way that they found it using some really cool sequencing techniques and prediction models, absolutely fascinating. So this is a really cool paper and a really cool advancement, because not only did we find some really cool molecules, it gave us a whole new technique to find even more. The answer is within you all along.
Also, humamycin, not bad. It's a lot better than base or verbukistan.
Oh, I gotta say it. It's a myosin. It's a myosin that kills stuff, so why not? Human myosin. It's so much better, and it's easy for future doctors and patients to remember. I want the comes from human poo. Oh, the humamycin. Oh, of course, yeah, right here.
Well, that's right. A mycin that comes from human. I can't wait till we have a patient base that's that educated. Please give me the drug that comes from your excrement, but mind you, I need it to be from the excrement of a virile, bearded man. Don't give me any of that child excrement medication. Let's move on to our next story. So we talked about finding bacteria to fight bacteria deep within our gut. A good gut feeling, if you will. But now we're finding bacteria to treat other conditions, and it turns out that bacteria is a lot like scotch and better when aged.
Absolutely, man. Old bacteria is best bacteria.
In my day, we had to climb uphill both ways through the snow just to infect an elderly person. You bacteria today have it easy.
Seriously, they will clarify you and put you up people's butts in an enema. That's to cure C. diff. That was a previous episode. Go back and listen.
And if you shoot water up somebody's butt, you have made an enema of them for life. So let's talk about what bacteria specifically we're speaking about, and it's salmonella. You've all heard of salmonella, usually in the latest food scare. I think it's made the celebrity rounds from Jack in the Box all the way to lettuce and bumblebee tuna. It's one of the leading causes of foodborne illness. About 48 million Americans yearly get some form of food poisoning, and part of the reason for that is that salmonella bacteria are really, really good at penetrating cells. It's an intracellular bacteria, meaning it is so good at hide and seek, it can get into your cell, and your body's own defenses won't be able to detect it. So, we of course found a way to exploit that.
Yeah. This is always what we want to do, and I always put in a little plug for the little parasite that I study, Toxoplasma gondii, which is also an intracellular pathogen. And some studies are being done in parallel in Toxoplasma, just like the study we're about to present here in Salmonella. So Salmonella is an almost completely obligate intracellular parasitic bacteria. It's got to be gobbled up by one of your cells, and then it makes a little home in there, and it can divide and kind of hang out, and then when it's ready, it'll burrow its way out and burst the cell that it was living in, kind of burn its house down behind it. So when you have salmonella and you're sick with it, it's a really bad thing. But if you were to say, hey, salmonella, you need to get into a cell anyway to live, why don't we make a deal, okay? Why don't you just infect a certain type of cell, number one, okay? While you're there, if you don't mind secreting some really virulent stuff to kill that cell, burn the house down around you, okay? And then we'll let you stick around for a while, all right? We can let you stick around and grow, and we'll actually even propagate your species. But in exchange, you don't kill us. How does that sound? Does that sound good?
It sounds like you're teaching salmonella how to profile.
If you, they're quite cellist. So these are, this is an attenuated strain of salmonella. This is not just, let's just shoot some salmonella and see if they kill tumors. This is a attenuated strain.
Meaning intentionally weakened and with the ability to infect a cell, meaning get inside, but not cause any kind of immune response or disease.
It's been messed with genetically, it's passaged through various types of tissue culture, and then it's been trained. It's been trained to, in this particular case, go to a prostate tumor and actually burrow in there, eat, divide, thrive just the way it's meant to, and lyse apart those tumors and actually shrink them down. So this was a paper in PLOS One, and this is wonderful because this is an open access research article, so anyone can read it, and published August 9th, 2016. Please go click on our Facebook site and like and subscribe and read the whole paper. These wonderful researchers went ahead and tested out this bacteria sample on a mouse prostate tumor model. So it worked beautifully. As you adjust the dose of bacteria up, the tumor shrinks down, and voila, you have a tumor-killing bacteria in a vial. Now, this is not at all the first time that we thought of using an intracellular pathogen, either a virus, bacteria, or parasite, to go ahead and burrow into a tumor and kill it. But this trial was a great proof of concept to show that you could do it in a living organism, you could do it fairly safely, and you could do it with a good amount of efficacy. So, baby steps, but, we're learning to make allies with some of our oldest enemies, and sometimes enemies.
Now, these salmonella are not killing the cancer cells just on their own by virtue of being in there. They're being loaded up with tiny little capsules of chemotherapeutic drugs in many cases, or with slight tweaks to their genetic material to make them deadlier. But they do only target cancer cells because they're taught to search for these growth markers that are on the outside of cancer cells. What made this story more interesting than usual is, in typical scientist naming fashion, this miracle strain, or at least this promising strain, is called, imaginatively, CRC 2631 for Cancer Research Center 2631 strain. But this strain was derived in particular from a sample that sat at room temperature collecting dust for 50 years. Basically, 50 years ago, some scientist forgot to pack up his station, walked out whistling, and everybody just forgot it until, cue music, some young scientist, hotshot, just got hired, maybe looking to prove his career, is setting up his desk when all of a sudden this topples out of a cabinet and he goes, I wonder what this is. Blows the dust off, takes it to his head researcher, principal investigator, and voila, as they say.
We should be pronouncing it voila. That's how it's spelled. So this is really just a first step. It's a beautiful use of an old strain to do some new tricks. And, we have to emphasize that this was in a very controlled mouse model. So there is a lot of research left to be done. But, we've used viruses to kill bacteria before. That's called phage therapy. Sorry. And now we're taking a proposed idea which might be more than a century old, using intracellular pathogens to lyse open tumors and putting it into practice. So it would be a wonderful thing if this worked. Let's move on forward, and thank you, Doctors Kazmariak et al. And yeah, go read the paper, and hey, lyse.
Yeah, this study has the potential to drive people absolutely nuts, which could be dangerous if they have an allergy.
Oh, did I hear a transition, Dr. Josh?
Well, in order to make a good segue, Santhosh, you have to be able to have some skin in the game. And our last story, our last science story of the evening is there is a skin patch to treat peanut allergies. And this, again, falls in with the rest of our theme of medicine that's coming soon, because this one also is not yet commercially available, but a wearable patch that you can use to treat peanut allergies has shown tremendous promise in a recently concluded clinical trial, specifically doing well among young children. And it is called in what is probably not the best name, the ViaSkin peanut patch.
Well, ViaSkin I like, because it tells you exactly what's going on. You are accessing, you're delivering medicine, or in this case, a therapeutic, via the skin. I can agree with, and thank you, scientists.
You might as well have called it Voila skin. All these V words are so confusing. But as I'm sure you know as a pediatrician, Santhosh, peanut allergies have been on the rise, especially in the Western world. And now, I know we talk about gluten intolerance, we talk about lactose intolerance, but not mentioning these legumes is frankly just nuts, because it is about 2% of all Americans cannot tolerate peanuts, and it has become the leading cause of food-related anaphylaxis and death.
Yeah, and we're not quite sure why this has happened. All throughout, some people blame something called the hygiene hypothesis, which we have covered before and will definitely cover again, meaning that, our immune system was really adapted to fight things all the time. We were supposed to be surrounded by things that would constantly make us sick. So it would fight, 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 fight. And now that we've taken care of a lot of those, bacteria and viruses in our environment because of sanitation and vaccines, the immune system's bored. So it has decided to go ahead and attack things which don't have anything to do with pathogens, like peanuts and ragweed and stuff like this. So now we have to find a way to tell our bodies that, hey, peanuts are cool, man.
Well, it is a good study, and the way it works is you put this patch on your arm just like a nicotine patch. So I guess if you're trying to get your kids to help quit their peanut butter and jelly habit, although if they have a peanut allergy, they should not have a peanut butter habit. It would be quite deadly. But you put the patch on, and it will administer small amounts of peanut protein directly through the skin. Now, this might sound a little bit dangerous for people who have peanut allergies, but it works off a system that we already use in medicine called desensitization. So for people who have a penicillin allergy or some kind of drug, and that's the only drug we can use to treat them, the allergist and immunologist, this is what they get paid the big bucks for, is precisely measuring out a microdose to teach the body how to desensitize and lose that allergic reaction.
Yeah. Well, it sounds a little bit counterintuitive, but you're actually feeding the body the same thing that is making it allergic or inflamed, but in teeny tiny doses and stepping that dose up until the body goes, oh, hey, this has been circulating around and we're not.
This study just concluded. It was a 1-year clinical trial, and the patch was developed by DBV Technologies, and it's shown to be effective and safe for children and young adults. So how did they do it? They took volunteers with peanut allergies ranging in age from 4 to 25, and I like that they give that big an age range. It's good, but it also makes me wonder about this volunteers business, because I'm imagining a 4-year-old, would you like to wear a sticker that'll let you eat peanuts? I mean,
No, no. So, so, so we have to clarify a little bit here. It is called a volunteer trial, but when you do have children involved, you have to have full consent from parents who understand what's going on and they give assent or consent for their kids. So yes, that is like a kind of surrogate consent, but what you're actually doing is consenting mom and dad, not really.
now, Billy, this is a magic sticker that as long as you wear it, lets you have the power to eat peanut butter. Just, just like Wolverine.
Stop it! You're scaring all of our listeners. Oh, which, by the way, Josh, I have the perfect analogy of immunotherapy to phobias. Like, for instance, like if you're scared of clowns.
What? Who? No.
So, we could actually, like, get you not afraid of clowns by, like, first introducing you to, like, a tiny little harmless doll of a clown. And
Dolls are my second biggest fear.
No, but like a representative, and then you move on to like, life-sized clown, but then, but it doesn't do anything, but then like a real clown, but it's far away, like it's really far away, and it's just standing.
These all sound absolutely horrifying.
No, but with enough like gentle immersion, no longer fear clowns.
I'm gonna put a doll of a clown by your bed just to see what happens.
Okay. Evidently, I have utterly and completely failed to communicate the idea of immunotherapy to, to our audience. And you...
I'm not conning around anymore. For the study, they took these volunteers ranging in age from 4 years to 25. They were either given a high-dose patch that had 250 micrograms of peanut protein, or a low-dose patch, or a placebo. And every day, the volunteers would put a new patch either on their arm or between their shoulder blades. So exactly like the nicotine patch. Besides it being pretty convenient and easy to use, pretty much everyone involved in the study was able to use it correctly, which is important because you are giving directions to children. After 1 year, the volunteers were tested to see what their peanut tolerance had, if it had changed, and to what degree. So both low-dose and high-dose patches showed that they were now desensitized, but even more impressive, kids between 4 and 11 showed the greatest amount of improvement. So when you're young, strengthening the immune system works even better. And this is a kind of treatment known as epicutaneous immunotherapy, or EPIT.
And this is a much gentler way of actually desensitizing people. We used to have to do the same kinds of desensitization for, the same year period, but actually give subcutaneous shots. You do a little injection of a diluted antigen, in this case peanuts, but you could do the same thing for any food allergy, for instance shrimp, and just inject a little bit of it and allow the skin to take it up, the immune cells in the skin to kind of process the antigen and show it to our other immune cells, like our T cells, and show it to be a benign set of molecules, such that when we ingested it, so that the antigen came through our mouth and our intestines and our stomach, It would not be in a horrible way where you'd break out in a rash, or your tongue or your throat would swell up, in a way that was trying to defend you from more of that stuff getting into your body. So this is a great way of, through the skin, using the organ of the skin as an immune tolerance screen to actually very gently cool down the immune response to an antigen. So it's a great proof of concept. It's a beautiful trial. Hopefully the product will be available soon, and we'll be able to expand it not just to peanuts, but to other allergens like citrus and shellfish and other common food allergies.
I'm still just picturing a nicotine patch, like, hey, what's that you got there? Oh, I've been trying to quit shrimp for ages.
No, they're trying to start shrimp for ages. I'm trying to get back on shrimp.
That's it for the journal stories this week. And the nice thing is all of these already exist, and although they are in trials, they are definitely previews of medicine that is coming soon. And over the last year of the show, I've taken a lot of opportunities to speak with people I've met while traveling, as well as listeners. And we're going to start giving you some of their travel tips and travel stories. So we'll hear one in just a moment. And if you have a story that you would like to share, leave us a comment or message on Facebook or call our Google Voice number, which is right down below in the show notes. And you may hear yourself giving out your own, just the tip. So let's take a listen to our guest of the week.
Hi, I'm Yokohama from Mina, Japan. Oh! I'm kidding. I'm just kidding. I'm Mina from Yokohama, Japan, and my favorite place to visit in the world is New York. And well, first time when I go there, I was a student and I was in the language studying program, so I stayed there for a month. And for the first time when I'm there, people say like people in New York is kind of cold like that. I thought they might be cold, but it was different. Like they just respect others, and when you are in trouble, people gather together and ask you, do you need help or things like that. So, and also there's a lot of place to visit, and there's famous, like buildings or theaters or whatever. Whatever, just looking around is so fun for me because it's so different from where I am. And yeah, just don't forget to bring sanitizer with you because it's dirty. Well, it's not dirty. It's getting better, but it's still dirty than Japan, so you need to, bring your sanitizer for your safety. And that's it. Thank you for listening.
So, there you have it. And as always, we love to hear from you. Leave us your comments, concerns, and questions. You can support us spiritually, emotionally, and financially by going to either our Facebook page and leaving us a comment, or wherever you download your podcasts, such as iTunes, and leaving us a rating or a review. If you'd like to support us financially, please go to our Patreon page. We have rewards for almost any level of donation. No matter how great or small, we do appreciate all of you. And Santhosh, we have finally hit 1,000 subscribers.
Oh, I love you people so much. Are you kidding me with 1,000 subscribers right now? You guys rock, seriously. Thank you. Thank you so much.
So, I'm excited that I would have never expected our tiny little ramblings to reach this many people. I'm lucky when I can even get my patients to listen to me. So, this is really fantastic. But that's it for this week, folks. We always love to hear from you from whatever means you care to contact us. Our theme music is composed by Rachel C. Leisure. This episode is produced by me and the Travel Medicine Podcast crew. And until next time, as always, happy travels.
Happy travels, guys.